Okay, so this is how you do problem number 6 on the chapter 13 homework of Hooke's law. So the first thing it requires you to do is obviously draw a diagram. So in part A, it says that determine the tension in the bowstring. So what you need to do is just the sum of all forces. So the sum of the forces in the x direction is the force applied by the person's hand. I'm just going to use the variable F. And because you have two kind of like two different parts of the bow, which is this part and this part, you're going to need to find the tension in each one of those. So minus t sine 35, because obviously the x component of this part pulls it this way and the x component of this part pulls it this way, so equals 0. So once you do the algebra, you get F equals 2t sine 35, and you can substitute F for the force, which you know to be 375 newtons. And once you get that, you can solve for T, which is about 327 newtons. And for the second problem, it keeps the variables the same. However, it wants us to replace the hand of the archer with a spring, and it wants to find the spring constant. So we know that the force will stay the same as a 375 newtons, and we know that the distance the spring is stretched from its normal position is 0.3 meters, or 30 centimeters. So we can use the formula: the force of the spring equals negative spring constant times the distance it's stretched from equilibrium, to get negative 375 newtons minus k, then x is 0.3 meters. You divide both sides by 0.3 meters and you calculate for k, and you should get about 1 to 15 newton meters. And that's how you do problem number 6.